Hey guys, welcome to my YouTube channel. So in this video, we're gonna look into normal distribution. So normal distribution, this is a normal distribution curve. So it has some properties. So it has mean over here in the middle. So it has a symmetric behavior. We call it normal distribution curve or a bell-shaped curve. And it has a symmetric behavior and it is finite in both directions, and then you can see it is continuous as well on either way around. And here it has a only single peak, so the maximum value is over here in at one point, which is at mean. And then for this, so here like 95% of the data fall between approximate 2 standard deviation of the mean, and then 99% of the data will lie over here approximately 3 standard deviation of the mean. So right now, for example, mean is over here, so we can represent mean with the mu, and standard deviation as sigma. So here mu plus standard deviation, mu plus 2 standard deviation. Similarly, here on this side, mu minus standard deviation and mu plus 2 standard deviation. So the ideal normal distribution curve has mean as 0 and then the variance is 1. So here how we write mathematically, so x is normally distributed with mean and variance. So as we said, the standard normal distribution has a mean of 0 and the variance is 1 for that. Okay, so here when we are gonna solve problems with normal distribution, so here we need to remember z-score. So z-score is basically standardized value, and here we are given a coding formula which is like z is equal to x minus mean over standard deviation. So we will be using this formula, but however the important point here is we will find the standardized value. So we convert any value into a standardized value, and then we can apply normal distribution to it. So how we will do it, like for example, if we have a mean given to us, so let's say mean is 56 and the standard deviation is 7. So from here we can find the standardized score, but we need the value of x. Let's say if we have the value of x as 70 and we want to convert it into a standardized value. So from here what we will do, so z is equal to 70 minus 56 over standard deviation, which is 7. So we can simplify this. So we can use a calculator over here. So 70 minus 56, and then this is equal to 14. So 14 by 7, so this is 2. So standardized score for x is equal to 70 is 2. So once we know the standardized score, so after that the actual problems actually what it's coming in AS or statistic 1. So there how we will use the table of values actually to figure out any probability, because you know here in this bell-shaped curve, so the total area under this curve is equal to 1 whole, so which is 100%. So the probability for this is 1. So 100%, 100%, so this is equal to 1 over here. So if we are given a probabilities, so how we will use the table, or if we know the z-score and using that z-score, how we will find the probabilities from the table. So that is actually the main topic, so where students struggle. So we will look into few problems for that. So let's see if you know the z-score of 2.63. So how we will figure out the value for this? So here we will look into that now. So here, as I said, because right now we are taking this situation, so where mean is 0 and the variance is 1. So we already know the value of z, which is 2.63. So we simply need to read this from the table. Okay, so let's see this table. Actually, it's given uh, in the even in the exam. So here, for example, what we are interested to find the value of 2.63. So 2.6. So first of all, we need to read from this side. So we will look where 2.6 is. So here 2.6, and then from other side we will need to see where 3 is. So 3 is right over here at this point, 0.9957. So this is equal to 0.9957. So what we did, we simply looked 2.6 at 3. So that's how we were able to find the probability of this. Since you can see over here in this table, so these are z-scores. So z-scores are right over here, and based on that, this is the probability given to us for that. Okay, so this was a positive value, so we get a probability over here. But in case if we get a negative z-score, so which is 0. Let's say 0.6. So remember here, if we have a negative over here, so what we have to do, we need to subtract it from 1. So 1 minus phi of 0.06, because as we already said, like, it has a symmetric behavior. So if it is negative 0.06, so on the other side again it's 0.06, so that is positive 0.06, because the table does not give us negative values. So what we will do, we will just simply subtract it from 1, and once we're going to subtract it from 1, so automatically it will be the same value due to symmetry. So you just need to subtract it from 1, and then you will be looking at 0.0 at 6. So let's go back here. So 0.0 at 6. So that is 0.5239. So now we just need to subtract these two. So again, we can use a calculator over here. So 1 minus 0.5239. So that will be equal to 0.4761. So here we figure out, so if we are given these two values, so we can positive and also negative, so we can easily figure out using this formula these values for, or the probabilities of this, or even we can say area for that. Okay, let's see another example over here. Now if we particularly said over here, find the probability of z less than 1.08. So then in this case, again, if it is less than 1.08, so what we need to do, we simply do phi of 1.08, and then again we will look into the table of values. So here what we need to do, we need to look at 1.0 at 8, so 0.8599. Okay, so that is for less than 1.08. Similarly, if we know the z-score and it says z is greater than 0.76, so here in this case what we need to do, so whenever this is greater than greater than, so what we need to do, 1 minus phi of 0.76. So here what we can do here, let's try to sketch this to understand. Okay, so 0.76 is somewhere here, because as we know the 50% is due to symmetric behavior, so 50% the mean is here in the middle, so 50% data is on this side, so which is 0.5, and 0.5 is to the other side, and then the total is equal to 1 whole. So now it says 0.76, so 0.76 is somewhere here, so greater than that, so this region. So now in this case what we can do, if it is greater than 0.76, so what we will do, we will subtract it from 1 again. So once we will subtract it from 1 again, so we know the z-score, which is 0.76. So we will look for 0.7 add 6 from the table of values. So 0.7 add 6 is 0.7764. 0.7764, and again if we subtract this from 1, so we will get 0.2236. So here as what we can see over here, because it's greater than this, so we know till here, so we are interested to find the area under this part here. So if we want to find the area under this part, so what we can do, we can find the area from here to all the way this place. So what we did, technically what we did over here, so we found the area under this part, so which is phi of 0.76, and then by subtracting, because total area from here to here is 1 whole, so by subtracting this region from it, which is phi of 0.76, so we were able to find this, the white region over here. Okay, let's have one more example for this. So now probability of, let's say, z is less than negative 0.72. So now again you can see it has a negative value over here. So if it is negative, so what we do, we again subtract it from 1 minus 0.72. So 1 minus, so 0.7 at 2. So 0.7 at 2 has this value 0.7642. 0.7642, and by subtracting again, so 1 minus 0.7642, so we will get 0.2358. So let's summarize this quickly. So what we said over here, so if we know the z-score, and then if it is greater than that, z is greater than any number, so we subtract from 1, and if our z-score is also negative, so we also subtract from 1. So we'll see some other example in the next video. Stay tuned. See you.